So problem 9 says use the max-min inequality to estimate the value of 0 to 3 pi over 2 of cosine squared dx. So we need a function where we know it has a maximum and a minimum, and it gives you a hint here that cosine of anything is always going to be between -1 and 1. So this means that I can say, well, cosine of x squared is also going to be between -1 and 1. So this is going to represent little m, and this is going to represent capital M. So the max-min inequality says, well, if I take these bounds, right, these are the heights, and I multiply them by the width of the interval, right, then the integral itself lives somewhere in between here. So let's fill in our values. So -1 times b minus a, which is 3 pi over 2 minus 0, has got to be less than or equal to the integral from 0 to 3 pi over 2 of cosine of x squared dx, which is less than or equal to +1 times 3 pi over 2 minus 0. So if I simplify the left side, 3 pi over 2 minus 0 is 3 pi over 2 times -1 is -3 pi over 2. That's less than or equal to the definite integral of cosine of x squared dx, which has to be less than or equal to +3 pi over 2. So while I don't know what the exact area is for this function, I know that whatever it is, it's somewhere between -3 pi over 2 and +3 pi over 2. So we said we'll calculate the area if the heights are always 1. Then we calculated the area of the region if the heights were always -1. And we said, well, the true value is somewhere in between there.